don't know. I don't know if I've learned because I mean I always think it's a good idea, but I never remember.
Right.
Like
Well, and it's amazing. I mean, it's one of those things where I think we've talked about this. I think before 2020, I knew what Zoom was,
hmm
and I may even have used it once, but it was not part of my normal
Yeah.
realm of things that I thought about. And so it's one of those interesting things where I notice now how much, well, like this conference, the big history
hmm
conference, right? I mean, it's it's pretty significant that you can give a talk, have a discussion, and go back and look at all the things and reflect on them and whatever. Like it really makes a real
Yeah.
difference to the world that that's possible. And we sort of could
hmm
have done that before, but in practice, we tended not to do that. And now it's just become part of our automatic thing that we do. And I realize how like I'm writing up a bunch of stuff and not having to be taking notes and trying to have a conversation and all those things. Like I mean, I still like in-person conferences, but
Yeah.
I realize that there's kind of, in some ways, more intimacy and more dynamic nature,
Flexibility.
yeah, flexibility to the interaction that you have in a small group on Zoom where you can just chat, reflect, pause, and know that everything that you have is going to be stored to
Yeah.
follow up on, like you and Ashley and I, our conversation is the
hmm
same way, right? There's a freedom. There's a freedom of knowing you can talk and also knowing that if you want to then share it with somebody and bring them into the conversation, that it's so easy
So
to
easy.
do that.
Yeah.
So anyway, yeah.
Yeah, no, I agree. Like the I don't know, I feel like, in lectures and stuff at school, like there's always just kind of like a little bit of anxiety that like I'm missing something that is would really help me understand what is being talked about because like I was like writing something down or like, doing those things. So there was always kind of just like that anxiety of like, what if I miss something
Hmm.
that would make everything click?
Hmm.
But because I was like writing something down, but with like, recording like Zooms and stuff, like that's completely gone because it's like, well, if I miss something, I can like
Hmm.
rewatch it and I can
Yeah,
make sure that I didn't miss anything important when I was writing things down and
yeah, for
those
sure.
kind of things.
Yeah, I mean it's really interesting how so much of our mental landscape is so subtle about how
hmm
we hold a frame of mind, right? I mean, I think about sort of what we're always trying to do is find this. Well, it's sort of related to, the text conversation we had about when I
hmm
got to this point where, oh, I'm overwhelmed now. I
Yeah,
can't do
yeah,
all these
yeah,
things.
yeah. Uh-huh.
And if we can notice those things and stay in balance,
hmm
how calming and liberating at the same time that is. And I think it's true for our use of technology too, right? Where we're trying to
Yeah.
find the space where having our phones and having social media and all these things are truly valuable as
hmm
long as they don't control us and we keep them
Yeah.
all in balance to find out reflectively sort of where they're useful and where they're hurting us and where it all sort of fits together. I'm experimenting in at least I mean I haven't tried it yet, but I'm experimenting in
hmm
my development of courses of trying to think about the intro physics course, that you TA
hmm
for the lab. Um, it as it settled into it's a fairly large class, which has some challenges because now it's 70 plus students in a lecture hall, and so you
hmm
can't do the same sort of interactive things. And anyway, so what I've settled on that I'm going to try next time is, but well, there's a whole bunch of pieces to it, but I'm gonna record all the lectures. So
hmm
I'm going to pre-record all of the lectures, so there'll just be one a week that'll be like the
hmm
topic for the week. and it'll be kind of a flipped classroom sort of thing where,
Uh-huh.
you have to watch the lecture before class.
Mm-hmm.
And then, and it's always a challenge because it's a big class. It's at 8 in the morning
Yeah.
and all those things. And
Yeah.
so one of the things I think is most valuable is to work on practicing focus, like we were talking
Mm-hmm.
about, the
Mm-hmm.
giving your
Mm-hmm.
focused attention to something.
Yeah.
And when it's early and people are kind of filing in at different times and whatever, hard to
Yeah.
do that. And so what I'm going to do is so the actual lectures with the content, I'm going to, like I said, record and have that be something you watch outside of class. And then
Mm-hmm.
to kind of balance the time, and still be a weekly homework assignment.
Mm-hmm.
And then to kind of balance the class time aspect of it, I'm going to divide people into groups of like 20 or
Mm-hmm.
25 or whatever it works out, a third. And for attendance purposes, you're only absolutely required for grading attendance purposes to be at one of the three class periods. So
Mm-hmm.
like to balance out that you have to watch the lecture outside of class,
Outside of class. Mm-hmm.
you only have to, and you can watch it at whatever time works for you to absorb information, and you can watch it as many times as you want and so on.
Mm-hmm.
And then you only have to be physically in class once a week, but then
Mm-hmm.
it's going to be really um, focused. Like you have to be there on time to get credit.
Yeah.
You
Mm-hmm.
cannot have you're going to put away your cell phones for because
Mm-hmm.
we can focus. You can do that for 1 hour a
Yeah.
week. And it's all going to be, there's going to be no tech. It's going to
Mm-hmm.
be, I'm going to be at the board writing down practice problems. And then in the
Mm-hmm.
groups of 20 or so where we can work together and I can go around and it'll be small enough, we're going to be really focused on, we're going to practice these problems. And
Nice.
I'm going to make it so that like basically to get to pass the class, you have to go to one of those every week,
Mm-hmm.
but
Mm-hmm.
only one. So you can give me your full attention for those. And then for people who want to come like I'll do like slightly different problems every time. So same
Mm-hmm.
topic, but slightly different problems. So if you really find it valuable, you can come to all three if you want. Or
Yeah.
if you have a sporting event or a music event or something on the day that you're normally supposed to be there, you can come to the other day and I'll just keep track of are
Mm-hmm.
you there once a week for practice problems. So I think, I don't know, I feel like that'll solve a lot of the problems and it'll make it so that I think these days one of the most important things to practice is not the subject itself, but the ability to focus, like
Yeah.
we've talked
I
about.
agree.
So I'm just gonna
Yeah.
we're all gonna train ourselves
To
once a week.
focus.
We're gonna shut down everything else and we're gonna pick an interesting physics problem and we're gonna focus in our entire brain power on how do we solve
Mm-hmm.
this physics problem and sort of be in that.
And
And
would
even
you
if you
have
don't like
like,
physics, you can
oh,
learn that skill, that muscle
yeah,
of exercising your focus.
no, I agree. And would you have like paper and pencils like available so like people can't even use like their like laptops and iPads and stuff?
I'm glad you said that. I've been thinking. I'm curious your opinion as a recent student. Because
Yeah, no.
that's what I'm thinking. I think it would be
Hmm.
better if we just absolutely shut out all tech. Like I
I
know people
agree.
like to do things on their iPads,
Hmm.
but I think just let's just be here for one
Yeah.
hour. Nothing that takes you anywhere else but here with what's in front of you.
Yeah. So I guess like people having like a binder for the class, like with all of their papers, like
Yeah.
with all like their like problems and stuff on it, so they can like keep it. Because I feel like the only like probably the only reason why I have like this iPad is because like I hated like growing up at the end of the school year, just like having this just so many journals and binders and papers that I'm like, I don't do I like I want to keep this all because I think it's valuable to have, but like it takes up so much space and I don't know where to put it.
Yeah.
So like having that on my iPad was nice. But I mean,
Yeah.
if it's for like one class, like, one small binder with a bunch of like problems like written out in it, I don't think that would
Yep.
be. too horrible.
Yeah, well, and I'm glad we're having this conversation because I think your idea because here's what do you think about this?
Hmm.
Because I agree, I do the same thing, right? I keep things in my iPad, in like Notability or whatever, where I
Hmm. Hmm.
know I can have it all. But it's also really easy to take a picture or a scan of something
True.
and then
Yeah.
import it into a
Hmm.
Notability app or something like that. So I wonder I could be, so certainly someone who wants to use paper for the whole thing could just bring a notebook and just do it in their
Hmm.
own notebook. But
Hmm.
those who are wanting to use an iPad, that would be a good way to accommodate that,
Yeah.
is to say, in this class period right now, we're going to do this one task only on paper. And then I
Hmm.
can just demonstrate at the beginning, like here are a couple of apps you can use to scan it into a PDF or whatever, which is easy
Hmm.
to
Hmm.
integrate. And then just say, at the end of the class period, just now take out your phone and scan this, everything that we've worked on, and then you can just feed that into that workflow of things. I think that's a good way to do it
Hmm.
because I think,
Yeah, I agree.
yeah, I think part of the benefit of this whole approach is to have an hour a week where your mind is free of any possibility of going anywhere else to
Yeah.
look for information. Like we're just going to look
Hmm.
right where we are. Yeah.
Yeah, like especially like with the younger generations who are growing up with like
Yeah.
getting iPads when they're like 2 years old,
Hmm.
and
Hmm.
then like being like be having so much time to like develop on that, but also be grown so attached to like the attention spans of the students that are coming in like now.
Hmm.
Well, maybe not exactly now, but like
Students who are on their way up.
soon.
Yeah.
Yeah, students who are on their way up, they're getting their attention is going to get really, really, really hard.
Yeah.
Like it's going to be, I don't
Yeah.
even like it. The school itself is going to have to change to accommodate for all of these people who are coming in because
Yeah.
like I mean, my little brother like, got an iPad when he was like 2, and just
Hmm.
kind of like watching that like develop, like it's kind of horrifying that
Yeah.
like, and then
And
even like teaching tap to kids, and like it's a lot harder now when I was teaching tap to kids. um like I'm a bit ignorant about that because I haven't been teaching like this generation of kids. But yeah, like even when I substituted at Neil Armstrong Middle School
mhm.
for my hours for that class, um like just it was crazy like how hard it was for those students to sit still and listen. Like
Mhm.
it was crazy. So
Mhm.
yeah, having like retraining that is going to be really important, I think,
Mhm.
in school, and
Mhm.
like shutting out all possible. And it's going to be hard, and there are going to be a lot of students who are going to rebel because it's like it's a part of them. It's like, it's really hard to
Right.
it's going to be hard to get out of that habit, especially for how long they
Right. If that's
were
just
growing up with it.
Yeah, if that's just what you're used to doing in the background, no matter what else you do. And I'm hopeful that I think because I see it with a lot of students,
Hmm.
your class or around your
Hmm.
generation. I think I've seen it of kind of at least there's some recognition that that's a
Hmm.
problem.
That's
That
good.
maybe
Yeah.
you don't notice, maybe the students don't notice while they're in middle school, but by the time they
Hmm.
get to college, they'll start to notice that it's a difficulty.
Yeah.
And I
Hmm.
think
Hmm.
if we can keep the thread of, like what we're doing right now is a great example that
Hmm.
it's not a Luddite sort of thing where you're rejecting all the technology and the benefits of it.
Hmm.
You're just taking control in a way of how
Yeah.
that you're reminding yourself that your own thought process gets to decide
Hmm.
how the technology is going to be used rather than there's a sort of an automatic pattern where the technology can start to control you. And so that
Hmm.
this
Hmm.
training isn't to wean you off of the technology, it's to
Yeah.
make it so that you can
Have
use it,
more
right?
control over
Yeah.
it.
But
Yeah.
by having the mindful time helps you then consciously decide when the technology is a help to what you're trying to do,
Hmm.
um, with sort of a deliberateness, right? Where we can, we have you and I have our time where we can go off and sit with a piece of paper or a book or something or
Hmm.
under a tree and reflect on something um, and then benefit from the technology to be able to write a paper online and have this
Yeah.
conversation online and whatever. But it's
Hmm.
not because we're doom scrolling. We're trying to
Yeah.
we're trying to find things where it's dominating us. We're like
Hmm.
consciously choosing to. Yeah, one more thing about that is I just had this
Yeah.
interesting experience. We're getting ready for the choir concert, the holiday concert on
Yes.
Tuesday.
Yeah.
And so I've been trying an experiment this semester of partly just because of the way Dr. Green makes all the music available
Hmm.
on a Google Drive.
Hmm.
I have my iPad that I use for notes and stuff. And I've tried and I know a lot of other students do this where they use
Hmm.
their iPad for their music, which
Hmm.
is really nice in a lot of ways. And so I've been trying all semester that experiment of using that. And I, so because of the way we're doing things with the concert, where we end up having to set our music down sometimes,
Hmm.
and just because of the shuffle of the music and the way it looks, and we're not using music stands, and so we're actually holding
Hmm.
it, so it looks a little odd to have the iPad versus a nice black
Right.
folder. So anyway, so last week I decided, okay, I'm gonna just print out the music and tape it together so that it'll go into the nice folder, with
Hmm.
the little string attachment points.
Yeah.
And
Yeah. That's
so,
nice.
yeah, and so Tuesday was the first time that I participated in a rehearsal this semester since early on, where I had paper music instead of my
Hmm.
iPad. And I just was struck by how much more peaceful I felt, right?
Wow.
Like it was just, there
Uh-huh.
was a very interesting, and part of it is because the 2 pages, it's kind of like reading a book versus reading it on your phone or something, even if it's
Hmm.
the same content. There's something about the 2 pages and the holistic view that you can see, and you have a very definite, like, now I'm going to
Right.
turn the page and I'm going to get a new
Hmm.
view. Whereas when
Hmm.
I was doing it on my iPad, I was sort of constantly scrolling, and
Right.
I was always trying to keep it centered,
Hmm.
it sort of operated in my brain differently, where I was
Yeah.
never sort of still and soaking in the holistic view of where the music was at that point. I was always kind of
Hmm.
tunnel vision on one little
Yeah.
piece. Anyway, so it was just interesting to
Whoa.
notice how it didn't seem to me intellectually and abstractly as if that should make that much difference.
Hmm.
And it may also be the light, right? That it's just not having
Right.
the screen light coming into my
Hmm.
eyes and my brain is a different feeling. But I was surprised and struck by it. I was just, oh, this is better. I can just sit here and be with the music and sort of relax into it and not feel something. Anyway.
Yeah, I was gonna like the same thing with like this textbook and this textbook.
Mhm.
Like having the actual book, I'm like realizing like, wait, this is actually really nice.
Mhm.
Like I don't know, it's just it's
Mhm.
real. Like
I
it's
know.
an actual thing, and it's
Yeah. It's
not some mystical black box
right.
thing.
And it's fascinating because it's still information and it's still going into
Hmm.
your brain and being processed in a way. But so it's just a good reminder of how, it's the same thing like when I was advocating for note cards,
Hmm.
right? There's
Hmm.
something very real about getting up in the morning and seeing in the middle of an empty desk with a beautiful bamboo sort of, that I can run my hands over and
Uh-huh.
sort of feel there's a nice note card
Milk card.
with a nice flowy pen writing the letters
Hmm.
on it or whatever that just draws me into, oh, there's an idea that
Hmm.
I can feel and sense intellectually at the same time, and there's something different about the perception. So it's interesting. I've been doing, same thing. I've been going back to. I like having all the books on my phone in
Hmm.
Kindle so that I can
Hmm.
access a quote anywhere I am. But when
Yeah.
I'm actually going to study it and read it, I also want to have the
Want to
physical
have
hard
that.
copy book because it enters my awareness differently when I can. And
Hmm.
even we've talked about this, remembering, like I look at the bookshelf back there when my mind is trying to find a connection with an idea, there's an anchor with, oh, it's that book with that colored spine.
Hmm.
And it's that page that I can
Hmm.
picture where I've written something in the corner or something like that feels
Yeah.
very different than, oh, it's somewhere in this virtual
No, I
box.
had that same thing. Yeah, no, I didn't realize it until just now. Like having a journal for notes in class is
Mhm.
so much better because like I don't know, there's something about there's like more cues to trigger like my memory of something when it's like physically in front of me rather than
Mhm.
like it being like on an iPad. Like,
Mhm.
I like I wrote down like this equation that I need like on this side of the journal, like it was near the top, like it was like and it was fairly well into like the lecture, but it was a few lectures ago. Like there's so many more like memory points that would trigger my memory of like what the formula was. Like it not necessarily like where it like was. It's just like what was that formula? And I can like picture it and like the
Uh-huh.
more cues that I have, it's like, oh, the formula was like this because that's what it
Yeah.
looked like when it was sitting on that page, like that
Yes.
far into the notebook, like
Yes.
in that color or
Yeah, it's
whatever.
a third of the way down with purple highlighting around as a
Yeah,
box.
uh-huh.
And then next to it is this other equation that has this relationship to it and something.
Hmm.
So that I
Hmm.
think that's a lot of it too. Yeah, yeah, yeah. Yeah, it's pretty fascinating.
Yeah.
Okay.
So tangible things are um really important. And today I finally like actually like I've been kind of like thinking of like general questions like in my brain, but I haven't like like written it down or anything. But today like I was finally like no. Like I don't know. I woke up this morning and I was like I need to change the way I'm doing many things. Um and I wrote down like my question. Like I went to my questions document and I put like my other stuff on a different page and I
Mhm.
like started like this new format of just like putting a question and like kind of like elaborating on it like on my document.
Mhm.
But like while I was doing it, I was like, I want a tiny little journal for this, like a tiny
Mhm.
little like notebook that I can just like put in my pocket or something,
Mhm.
so that like throughout the day, like as I'm on the subway or like walking
Yeah.
around, and like I think of any more things to contribute to the question of the day, like I can just like go in and like.
Yeah.
But it's like I could do that on my phone too, but like
You
it's
could, yeah, absolutely.
like a
And
little
that
journal.
and that works for a temporary, like if you're somewhere where you don't have your notebook or whatever, you can write it down. But
Hmm.
there's something about, yeah, I'm gonna just a second, I'm gonna grab mine. That, this one won't quite fit in your pocket, but
Oh yeah, yeah,
like there's something I like about this
yeah. Hmm.
structure that I can put little sticky notes and remember, oh, that's where that idea was, and it,
Yeah.
has sort of
Yeah, I have one like not for I don't know. This
oh
is
yeah,
just kind of like diary-esque
yep, yeah, yeah,
things,
yeah.
like more reflective of everyday life
Uh-huh.
events, but
Yeah.
having a like a smaller like contemplative one. I think that would also help me like actually get in the habit of doing it every day, of just like
Yeah.
the excitement of, oh, I have a new little journal that I have for
Yeah.
this
Yes,
exact
yes. And if you have a nice
little.
pen that flows really
Yeah,
well,
yeah,
that sort of,
yeah,
um, yeah, I know it's pretty interesting how integrated, how integrated ourselves are, right? That
yeah.
we are not, if we are fragmented, we don't operate as well. And somehow the being non-fragmented means having something tactile and intellectual and emotional
Hmm.
all kind
Hmm.
of at the same time in some interesting way. Yeah,
Yeah, I agree.
yeah. And on
Okay.
that subject, shall we
Should we
shall we
turn
turn
over?
all of that into a pondering of black holes?
Most definitely.
And
So I don't know why I didn't think to do this. I did I wrote like the questions
uh-huh,
and like the succinct sentence on my iPad,
uh-huh.
but I did not put it in the document.
Oh, that's all right. I mean, we can. I
So,
mean, I feel like we're gonna finish it soon, and
hmm.
we'll just while we're talking today, well, I have some more thoughts for my section four that or section yeah four that I kind of had in my head, and then I haven't sort of put in. So we can work on it as we talk, I think, and then I'm interested in hearing what you thought about for questions too. So I
Yeah, no, I mean
go ahead.
the questions I think the questions were already there. They
Uh-huh.
just weren't as fleshed out.
Hmm.
Um, for I decided to keep I went into the document right before the meeting, and since like the questions were still there from when we wrote down, I just commented out the other ones.
Hmm.
But the ones I wanted to have them explore was um what effect cosmic expansion has on the results,
Hmm.
and
Good.
the photon planets.
Okay.
Um, so I
Good.
kind of started like on my iPad, I started like going into, more of the math and trying to like figure out like how we would incorporate these things.
Yep.
And for cosmic expansion, like I don't know if this is the most fruitful thing that I did, but I just kind of went in and incorporated the uh Hubble constant term into um our like, equations that we had on in our paper, just to
Hmm.
kind of see like what the like proportionality would be
Hmm.
with like that expansion term.
Hmm.
Um, so like I don't there's probably more that can be done to get more fruitful insights from like
Yeah.
expansion,
Yes.
but
So one
that's
thing you
what I
could do,
was
I mean, actually, just building on what you just said, I like what you
thinking.
said, right? Is you're putting in the Hubble constant and um, as a way of kind of parameterizing what the expansion does. I think I have a note in there from when we were talking about this before. Yeah. So at the, that's bullet point one, right? What effect is in the actual paper on the bottom of page 5,
Hmm.
where it says, what effect does cosmic expansion have on the results? So you might,
Oh,
am I right? Is that the
yeah.
same
Yeah,
topic?
yeah,
Yeah.
yeah, yeah, yeah.
So, um,
Maybe I should have
that
actually looked at that
1970,
instead of just
sorry, say
wrote
it
it
again.
down. Maybe I should have actually looked at that instead of just writing down what effect does cosmic expansion have on the result.
Oh no, that's all right. No, I like, I mean, in the spirit of the creativity and science, I think, where we said don't read the literature at first
Mm-hmm,
and
hmm.
just see
Yeah,
where
yeah.
your thoughts take you. I think it's good um that you just saw where your thoughts took you on that. But it occurs to me that since you're asking about like how to
Hmm.
make it concrete, what you might do that would be useful for your development anyway, connecting things, is just look at that Hawking paper
Hmm.
again. And because what he does is a very back of the envelope kind of argument where it's almost, I think it's almost exactly what you said. He basically uses the Hubble constant or the Hubble parameter because
Hmm.
it varies over time. it uses the Hubble parameter to put in what the, well, um, distance times the Hubble parameter gives you a velocity, right?
Hmm. Hmm.
Just
Acceleration times time.
well, right? Because let's see, right? Because I mean,
Because the
The
expansion is an
Hubble law is
acceleration,
basically,
right?
yeah, the Hubble law is basically V equals, you know, V in quotes. The rate
Hmm.
at which things are moving apart from each other is the Hubble parameter at that time, which is R dot over, yeah, which is R dot over R, right?
Hmm. Hmm.
The rate at which the scale
The scale
factor is
factor.
changing.
Hmm.
So H is R dot over R in the field equations. And you can define a velocity-like quantity, which is the rate at which the distance is increasing, is h, r dot over r, times whatever the distance between the things you're talking about is at that moment, right? So that defines a velocity.
Hmm.
And so roughly what Hawking argued in that 1971 paper, the way he derived the same thing we derived in the static case, he basically derived it by comparing the gravitational potential energy to the kinetic energy, quote, due to
Hmm.
expansion.
Hmm.
So you might even just use that same framework. You could, so you could say something like, what effect does expansion have on the results? Um, Hawking, 1971, derives a similar conclusion to ours for this, by equating a kind of kinetic energy to a gravitational potential energy to see when, if you get enough mass together within a small enough region to, um, let me make sure I make this chain of thought clear. Right. So we use the Schwarzschild radius to make an argument for what density will give you a certain will collapse, what density of material will create a region that'll collapse to a black hole.
Hmm.
Another, in an expanding universe, the way you can heuristically make an argument is to compare kinetic energy to gravitational potential energy. And so then that brings in conceptually the expansion rate, and you can put numbers to it with the Hubble parameter and make the argument the way Hawking did, which is basically that a little region will collapse if the gravitational binding energy is more negative than the kinetic energy in that size region is positive,
Hmm.
right? Which I think makes a cool thing for, in the
Yeah.
spirit of our like, you don't have to know anything other than things you can intuit from your
Hmm.
undergraduate training in physics to make an argument that there must be something about that that's going to define a size. And the thing you could have the students do is basically have them recreate Hawking's calculation and compare that to our calculation.
Yeah.
And then have them reflect on, why do these give the same answer? One
Hmm.
was comparing kinetic energies of an expanding universe to gravitational potential, and one of them is a static universe where you're solving for a region where the speed of light is less than the corresponding escape velocity due to gravity.
Hmm.
And I don't, I mean, I have some thoughts, but I actually don't. It's the perfect
Yeah.
kind of question to ask because there's simple calculations you can do where you don't lose your intuition,
Hmm.
and it leaves you with a conceptual question to ponder.
Mm-hmm.
which is why do these give the same answer? And why
Mm-hmm.
must they give the same answer? And what's the relationship then between an expanding universe and a static universe? And, presumably general relativity sort of ties those together, but the more I've thought about it, the more I find it's really useful to remember that the math only traces our thought process.
Right.
And so anyway, so I think that would be a nice nugget to put in there where there's calculations they can do,
Mm-hmm.
things to think about, and
Mm-hmm.
open-ended questions to lead. It has the nice combination of very concrete things you can calculate, but it also leaves you with open-ended questions to ponder. So I think is that clear enough?
Yeah.
Does that make sense?
Yeah.
I think you could, and
That makes
Hawking
sense.
actually does the calculation, but he's very order of magnitude. So I think you could
Mm-hmm.
you could do it more precisely,
Mm-hmm. Mm-hmm.
and so that you could have an exact comparison to our calculation. And I think that would be
Mm-hmm.
fun that you could that could be an exercise for the reader. Um,
Yeah. No, that's good. Okay, cool. That'll be fun.
and then I like your photon planets idea.
Yeah, no, the photon planets. Okay, I feel like I can do this. I couldn't do it when I was doing it, when I was working on it, but I feel like I could do this. Um, like there's what my brain was doing is that there's like some, we need some kind of like requirement or like criterion, like the Schwarzschild criterion,
Good,
but for, accretion or yeah, but like for like accretion.
good,
So like there's some kind of like where my thoughts were going.
good. I like this.
Um,
I'm going to write some words in that you can ignore if you want, but
okay.
while you talk.
Um, mm, where's- yeah, I was like saying like there's a certain radius for which the mass needs to inhabit to initiate the cascade of planet formation.
Good,
One could also ask what mass M has to be to initiate the cascade, though that probably depends on how far away the other masses are. So there's this kind of like dependence of like mass and radius and mass.
hmm
And then I was like, I mean, what if I just used like the escape velocity idea,
hmm
um,
good,
and tried to figure out, like I manipulated the escape velocity equation to find like the mass, but like with velocity, you wouldn't like know what the escape velocity is like for figuring out like the
good,
uh, planet accretion stuff.
good.
Um, so there's some kind of like format like
Yeah,
the
yeah, yeah. No, I like
velocity
that, Logan. That's
equation.
really good.
And we could, look at it in terms of like force of, gravitational force, G M1 M2 over R squared. But then I was also thinking that maybe we could also look at it in terms of energy instead
Good,
of
good.
like potential energy and kinetic energy.
You
There
you
might
are
be like some
thinking,
kind of criterion with energy
yes,
that might be helpful.
you are thinking like
Uh,
a well-trained theoretical physicist here. So good job. So I would just to um, I don't think precisify is a word, but
mhm.
to
Puts
to
me in the
take
right
to take
direction.
your line of thought and add some precision to what you can
Hmm.
actually do, right? Maybe to make quantitative, to take your line of thought and
Hmm.
make it
Hmm.
quantitative. I have a suggestion, and that you can then tie into the whole framework of what people have done historically
Hmm.
is, and you can even refer to something. So there's something called the genes mass,
Hmm. Jeans
that
mask.
you can essentially, but you can just mention that at the end, or I
Mm-hmm.
can make the link if you want. But you can just follow your calculation, and here you're asking for a criterion for how to do something instead of, you want to basically do the same line of thought as we did for the black holes, but you
Mm-hmm.
need a different criterion for what sets the mass scale
Mm-hmm.
than the escape speed of light, right? You need something else to set that.
Mm-hmm.
So what you can do is you can set it in terms of temperature. You know
Mm-hmm.
how we've been talking in terms of temperature?
Yeah.
So if
Well, I
if
mean, the question itself is,
what
uh,
temperature is needed to, right, what
yeah.
temperature is needed
Mm-hmm.
in order to make
Mm-hmm.
photon planets. So here's how you can make the connection, which is just filling in one piece with exactly what you said, right? So on the one hand, you have the gravitational binding energy, a certain collection of matter. So if I have a region that's like a cloud of gas and dust
Mm-hmm.
with particle, now I think maybe this is the way. Oh yeah, we're talking about photon planets. So let me ponder one more
Yeah.
piece here. Okay. Wait. So this is interesting. This is a very interesting line of thought.
Right, because
So
not a single photon has mass, but a collection of photons have mass.
correct. So interestingly, oh, this is fascinating. Okay, nice job of opening up this line of thought. So I'm gonna try something out, a thought chain, and you
Hmm.
feel free to disagree with it. And we're
Hmm.
doing the thing that we're saying we want all this to do, which is building models with our intuition and seeing what
Hmm.
they lead. So I'm gonna tentatively propose that you actually the okay, I'm just gonna say it. I'm not sure this is true, but I'm
Hmm.
gonna tentatively propose that the only structure you can form out of a purely photon gas of a uniform temperature is a black hole
Well,
because the escape speed that's going to come in is always going to be the speed of light,
uh,
which by definition makes it a black hole. Do you
yeah.
see what I mean? So a photon planet, I think, will be a black hole because if you try to make a structure out of a gas at any other, if you do your escape speed criterion,
Hmm.
the speed you're going to have is always going to be the speed of light, which is going to end up making it the Schwarzschild criterion.
Hmm.
And the reason I'm thinking of this is because I know when we talk in astrophysics about forming other kinds of structures, like
Hmm.
like these H2 regions, like a cloud of hydrogen gas, say,
Hmm.
you can there's a fairly well known in the field kind of criteria, which is this Jeans mass idea,
Hmm.
that if I want to get an estimate of, you know, I hand you a cloud, a huge, like those regions that you see with the star forming regions.
Hmm.
If I hand you a cloud of material like that, and I ask you what kind of structures are going to naturally form in that cloud, the way you theoretically derive that criterion is to ask, well, what's the temperature of that cloud?
Hmm.
And what are the masses of the particles that are making up the cloud, the individual
Hmm.
particles? Like, are they hydrogen
Hmm.
uh, atoms or nuclei? And then the size structure that's going to form is going to be determined by if you set the typical speed of the molecules as being about kT, or the particles, sorry, could be
Hmm.
molecules. If you set the speed as kT, roughly,
Hmm.
then 1/2 mv squared is going to be about equal to something on
So,
the order of kT, right? Like
hmm.
in thermo.
Hmm.
And so then that's going to define for you a typical velocity of those particles.
Hmm.
And then basically what you're trying to do when you decide what masses or sizes of structures are going to form is it's going to be anything that gathers together enough mass in a small enough region where the gravitational binding energy, the magnitude of the gravitational binding energy is bigger than the typical 1/2 mv squared velocity, which is kT.
Hmm.
Uh, and so what's cool is that you're sort of doing it um,
With a particle that has a fixed
with a
speed.
particle that has a mass, which means that it has a certain speed corresponding to the temperature. Whereas if you do it with a photon,
Hmm. It doesn't have a
the
mass at
uniqueness of a
all.
photon is that it always has the same speed,
Yeah.
and it that's fascinating. So how could we
Because,
turn that?
well,
Go ahead.
what if you like assuming that it's possible to have a planet made of photons,
Hmm.
and someone were to be like building a rocket ship on this planet of photons and wanted to like leave the planet of photons,
Hmm.
like then wouldn't that then introduce the need for an escape velocity that wasn't something made of photons?
Yes, yes.
Like, so I guess like the reason why the escape velocity in this case is going to be that of the photon is because everything involved in the process of making this planet is a photon.
Yes.
So if we introduced something in this system of photons that wasn't a photon, could that could we use an escape velocity of that? Like, is that something
Y-
like
y-
okay to do?
Yes. The only thing is, if you're talking about forming a structure,
Hmm.
if the structure itself is going to be made out of photon, basically, if you try to make a structure that doesn't meet the black hole criterion and you
Hmm.
try to make it out of photons, again, I'm open to being shown wrong about this, but my
Hmm.
my initial intuition that I'm practicing is that if I try to make a structure that is anything less of a density fluctuation than what will make a black hole, then the photons don't care that I've tried
Say
to
that
make a
again.
structure. You know what I mean? Like, so the rocket, back to your rocket ship. If I have a clump of mass that is clumped enough that it prevents the rocket from being able to escape,
Hmm.
that's certainly a valid thing you can talk about.
Hmm.
But if I'm trying to make a structure out of photons that will preserve that structure on that scale,
Hmm.
if I'm actually making it out of photons, then what matters in terms of talking about the structure is whether the photons can escape or not. And I, and I'm hedging a little bit because of course they do lose energy, right? They get redshifted as they try
Yeah.
to climb out, even though their speed stays the same, but they're still gonna get out. So you see what I'm getting at, right? That even if you use something else to talk about what can escape, if you're actually talking about making a planet, you're talking about making a structure on a certain scale.
Hmm.
And whatever you build that structure out of is sort of what you have to talk about in terms of making the scale.
Yeah.
Yeah.
Yeah, that makes sense.
So
And
just so you know, one simple thing you can do if you're willing to not have it be photon planets
hmm
is you could just say, um, suppose there is some other, you could just the subject line for this entry, the title for this entry could just be other kinds of structures or something like that.
hmm
And then you could say, um, something like you can apply this same type of argument to other particles that aren't photons that also form structures, but that don't interact very much with the photons. And then you could just ask them to derive the similar criterion, and then you can do everything you just said, right? But now you have the temperature and you have a
hmm
mass of the particle. So I think
hmm
I think that's a fun exercise, and then that's
Okay.
clean. And then I think what you could do usefully is you could ask the sort of open-ended question of it's
Could you
worth
make a
thinking
planet out of
about could you
photons?
make could you make a planet, along these lines, could you make a planet out of photons? Why or why not? And
That's really
explain.
cool.
And
I
then
like
and
that.
then you can let other people think about it without us having to necessarily resolve it. But I'm pretty
Mhm.
sure about what I said, but
Yeah, and now I'm trying to think of so like if you can only make black holes out of photons, what like why? Like I mean, I understand like in the math, like the only velocity that could happen is the speed of light, which is the Schwarzschild criterion, which is, you know, for black holes. But like what other like I guess what's another reason that's more that like not looking at like the math, like a more like conceptual explanation for how could it be that photon like the only possible accretion of photons is black hole formation.
yeah, and I think the conceptual argument, in the spirit of our note card questions,
hmm
I think the conceptual argument in a classical gravity kind of framework is just that the idea, let me try this and see if this works. The idea of making a structure at the level of this model means finding a boundary
hmm
where the particle that you're talking about can't escape that boundary, right?
hmm
That's what it means to form a
Right.
structure of a certain size,
hmm
right? As a general statement, regardless of what kind of object you're talking about, right? To
hmm
say that I'm going to make a structure means I want to find a boundary where the gravity won't let the particles get away, right?
hmm
And for light, by definition, that boundary is the Schwarzschild criterion,
Yeah. And
which by
also
definition is what we mean by a black hole.
I feel like one thing that my brain did was like since a single photon doesn't have mass, but a group of photons have mass, it would have to be like a really extreme case, like an extreme amount of photons to be able to cause any form of accretion. So, like, because of this extreme amount of photons needed, there's a probably maybe like a non-existent line between forming a planet and forming a black hole.
Yeah, yeah, yeah. So this is fascinating. This is really fascinating. I mean, depending on how much you want to go into this. So
Uh-huh.
here's an interesting twist. on the puzzle that you've just brought to my mind.
Uh-huh.
So now imagine a new situation where you have, okay, so imagine that you have massless mirrors.
Whoa.
Okay.
Uh-huh.
So, very, very low mass mirrors. Now, whether this
Uh-huh.
is possible, anyway, so you have, but we're theoretical physicists. We can at least
Hmm.
imagine massless mirrors, right?
Yeah. No,
So
yeah.
imagine you have a massless mirror material and you make little bubbles of this massless mirror material, okay? And you fill each bubble with, yeah, okay. So take our photon gas from before,
Hmm.
that you nicely described as, you would see uniform light everywhere in your experience if you could be immersed in this, right, in this fog. And you I'm imagining like little soap bubble thing that you can
Yeah.
blow bubbles into this world, right? And the bubbles are all the same size,
Hmm.
and somehow they have the ability to become transparent and opaque. And so when you first create them, they're transparent and they let some light in so that they're in
Hold on,
equilibrium
sorry.
with the
Some
light.
random person is calling me,
Oh,
and
oh
I
yeah, go ahead.
don't appreciate that. Okay, there we go. Continue. Sorry.
Okay, that's right.
Bubbles.
Right. So imagine a light-filled universe now with these initially transparent bubbles that you've now filled it with. And the bubbles are of a size scale, R sub B that you
Hmm.
can vary as a parameter in your
Hmm.
universe. And you have the ability to fill the space around you uniformly with these bubbles of your chosen size so that they come to equilibrium with the photon gas. Right? So
Hmm.
they're now, whatever the density of the photon gas is, they now share that.
Hmm.
Can you picture that, right? So,
Yeah.
inside the bubble, here's one of my bubbles. This is not round, but or not spherical,
Uh,
right? So whatever light is filling the surroundings, here's this bubble floating in there. Some light gets in and it's going, it's in equilibrium. It can go in and out or whatever, right? And then flip a switch, push your remote control button, and it's like those uh like blinds. It's like you're closing the
hmm.
blinds and suddenly now those bubbles become a reflective surface.
Hmm.
Okay?
Hmm.
So they're uniformly in equilibrium with everything, but now they become mirrors. And so
Uh-huh.
now whatever photon gas is trapped in it is inside at the moment when you make it reflective. Now those particular group of photons are now trapped.
Hmm.
Okay? You see where I'm going with this?
I think
Right? So
so.
now those photons are going to bounce around inside.
Hmm.
And now
Have a
they are
plan.
going to have an equivalent uh, invariant mass because you can take the average, you'll know how many photons are in that, and you can
Hmm.
add up, you can do the same argument we did for like two photons
Hmm.
crossing. And now now each of these bubbles becomes effectively a particle with an invariant mass, even though it's
Uh-huh.
made of photons.
Uh-huh.
And so now you could make a planet
Hmm. Out of
out of
photon.
those. And the reason I made the mirrors massless is so that the only mass you have to consider
Is the
is the
photon
mass scale
collection of
of the
photons
collection of photons. And now effectively you're making particles
out of
of a
photon.
certain rest mass by the size of bubble that you've made for a given temperature, right?
What?
Does that make sense?
Yeah.
I mean, this may be too far afield. I was just trying to run with your
No,
idea,
no, no, no. This is perfect.
but this
Like,
is fun.
would that, according to general relativity, would that then give this new particle mass that interacts gravitationally?
Yes.
That's crazy. Because like the mass is coming from the momentum of the group of photons, right? Like the net momentum of the
Correct.
group of
So it's
photons.
coming from this is an e squared minus p squared c
Hmm.
squared
Hmm.
momentum, essentially, right? Where the by putting the mirrors in there, you're making the average momentum zero.
Hmm.
That's the key. And so now you're making it so that let me be more precise. E is h nu for
Hmm.
a photon, right? Planck's constant times the frequency is the
Hmm.
energy.
Hmm.
So if I
Oh
see what I
yeah.
mean? So if I
Yeah.
add up all the photons in the sphere, add up so I take the average frequency. Yeah. So right, if I take the average frequency, multiply it by Planck's constant, and then multiply by the number of photons that will be in a sphere of that size,
Hmm.
then that becomes the energy of photons in that sphere.
Hmm.
And if that was a stream of photons all going in one direction, then they also have a momentum.
Hmm.
And the momentum will give me m equals zero
Hmm.
because because why? That's what it means to be a photon, right? I mean, because e squared minus p squared will be zero, right?
Hmm.
But when I'm talking about a collection of photons moving in all directions, because of the
Hmm.
mirrors,
Hmm.
then um, then I can make so sorry, just to close the thought, right? So then now basically what I'm doing is I'm setting P for the collection of photons. I'm using the mirrors for one purpose, which is to make P zero,
Hmm.
right? Once I've done that, then I make it so that the equivalent mc squared is just equal. So in other words, I've made it so the effective mass of these bubbles is now h nu over c squared.
Hmm. Hmm.
Yeah.
Whoa.
Sorry, n h nu over c squared,
Though,
where
how
n
would
is
that
the number of photons.
resolve like the problem with the planet of photons originally was that because we were talking about photons, the speed would be of the speed of light, which would then
The,
just give us the Schwarzschild criterion
mhm.
again. So having
The
a
speed,
collection of photons in these bubbles,
keep going.
since light always has the same speed, and I mean, light can kind of change speed when it's in a different medium, but it's still in the vacuum of space. So having a collection of photons, how would that change the speed at which the material goes of this planet that we're making?
Well, because now, um, and this will be a fun thing to next year for you to talk to Carla Cedarbaum about at Tübingen, because doesn't she work on
Uh-huh.
center of mass related
Yeah.
stuff? So you've by doing all of these shenanigans here, we've created new particles with a new speed at a given temperature,
Wow.
right? So the bubble, the individual photons move at the speed of light,
Hmm.
but the center of mass of the bubble does not.
Ooh,
right? I mean, I'm making all this up on the fly using
Right.
my intuition about physics, but I think that's
Even
right.
if it's
Yeah.
wrong, it's still a cool
Even
idea.
if it's wrong, it's still, I mean, even if
Yeah.
you can't do this in reality, it's exactly what we want, I think, which is
Hmm.
it's a useful thought experiment
Hmm.
to practice your intuition about how do all these things relate, right? So let's see, let's make sure we complete the logic. Does that make sense? That, essentially, your mirrored bubbles filled with photon gas are now traceable particles
Right.
that have a center of mass velocity. And that's the key. The velocity of the center of mass of these bubbles made of light.
Oh,
See what I
because
mean? It's
we
not the
can
speed of light.
use this new mass and the yeah, we can use this new mass to find what the velocity of the particle would be.
Correct.
Like using like one half. Well,
Yeah, using KT, and I guess it
yeah,
depends on whether it's relativistic or not. But we're
yeah,
that let's assume that we're in realms where the mass. Well, you could do it either way, but it's probably simplest first to assume that you have a big enough bubble where the mass is big enough for the temperature that you're talking about
to be
to
non-relativistic.
be non-relativistic. And that might be an unrealistic assumption because you might need such huge bubbles to do this that, the size of planet you form might be smaller than the bubble size, which of course becomes problematic, but it's still, in the spirit of what we're talking about, we're just trying to give students practice at following their intuition
Yeah,
without.
yeah,
Yeah, I think this would be really cool.
yeah, I agree.
And I've never seen anybody talk about such a thing before, so I
Uh-huh.
think it would be really, I think reviewers would enjoy just the thought
Pondering.
process of pondering it.
Yeah. And
So then,
unfortunately I do have to go soon,
okay,
but
that's fine. Yeah, yeah. So how about
I think
let,
I mean
let-
I can still meet tomorrow too if we want
okay,
to.
yeah, me too if you want.
Okay.
So why don't I think and now I'm really glad we have the recording because we didn't write anything
Yeah.
down, but we can let AI make a transcript of this if we want.
Yeah.
Um, so let's try. I think those two calculations are plenty.
Cool.
So let's try just, change the language to here are a couple of examples of questions that could be explored to give you a starting point of what
Hmm.
can be done in this. And let's just do two examples. One is what effect does expansion have? And what other kind of structures could you make? And here's a fun example to experiment with how one could do this. And then you can just
Yeah.
do the, you know, photons in mirrored bubbles or something like
Uh-huh.
that to illustrate the type of thinking and how crazy but also useful that can be. And if we could just work out those two examples
Hmm.
to sort of launch the creativity, I think that would be beautiful. I think that would be a really
Yeah.
nice piece. And then now that gives me super concretely what I know I'm tying to with those last couple paragraphs. And so I can finish that off. So why don't we just both work on those two things?
Hmm.
And then, if we're just lost in doing the calculations and stuff still, then that's fine. And then as soon as if it's tomorrow or whenever that's useful to meet to finish that off, then we'll do it. But just whenever. Does that make sense?
Yes. Yes.
But
Yeah, that sounds wonderful.
but now it's really well defined that like those are the only things we have to do to finish the paper. Um
Yeah.
so it's
But I mean, even if we don't like finish it soon, I don't know. I think this is fun. So,
absolutely right. I
oh
mean, I
no.
mean, yeah, I mean, I don't, I want to. I'm always mindful of it's easy to have projects that just sort of go on forever and you
Right.
never actually submit them. So I don't want to do that. But
Yeah, but I mean, I
in
feel
this
like we have the hardest parts done.
exactly,
Yeah.
exactly. This does not fit that pattern
Yeah.
where we're not going to finish it. So yeah, unless, you just tell me if you ever feel like you you need the paper in for an application or something like, but you've already got your applications for the next.
Yeah,
So,
I don't need
so
no application
yeah,
anymore.
no, yeah, right, right. We don't want this to go another year and not have it submitted, but
Yeah, yeah,
it doesn't have to be by any specific date. So as long as we are doing real things and having
yeah. As
fun
long
with
as we
it,
keep moving with it, like,
and we're continuing to move on it and be concrete with it. So
yeah.
okay, that sounds great.
Cool. I think tomorrow at the same time should work for me.
Okay,
I
let's
have,
just
I think I have that class tomorrow. I don't know. The last three classes have been canceled, so I hope I have
you hope you have the
um
class tomorrow.
the class tomorrow. Um, but it ends at 1:15, so I can just
Which
leave at
1:15, which
1:15.
is 10:15, right?
Yeah.
Okay.
Yeah.
Okay. Sounds good. So yeah, so let's plan on at least checking in at 11
Yeah.
tomorrow. And
hmm
if something comes up or whatever, or for either of us and we want to change the time, then of course we can do that.
Cool.
All
Sounds
right.
good.
Cool. That was super fun.
Right.
Nice job. And
Yes.
just to reinforce for you, right? It's super fun to see like you're doing the thing that we wanted this project to do, which is,
Yeah.
which is, so now you're going to, that thought process that you're doing where you're thinking through stuff. Now, next year, you're just going to learn general relativity and
hmm
other things will be as familiar to you as classical physics is now, but you'll be
hmm
doing the same intuition process to try to piece
Yeah.
things together. So this is fun.
No, I need this. I mean, honestly, like I think my favorite part of like physics and math is like just this. Like I think just thinking up crazy ideas
Mhm.
and like trying to like use like creativity and like imagination and like logical reasoning to like actually flesh out the idea.
Mhm.
And like even if it isn't like consistent with reality, I don't think that like it'd be cool
It'll,
if it was consistent with reality, but like just the mere pondering of crazy things
right.
like that, I think is really cool.
Some of the things will be consistent with reality, and
hmm
it's like you said nicely at the start of the paper, it's the connecting, using a model to
hmm
connect assumptions to consequences. That's what we're
hmm
doing, right?
Yeah.
We're assuming that there's this framework that logically fits together consistently. So then we
hmm
can say, well, what if we assume this within
hmm
that logical structure? What will some consequences be within
hmm
that model? And that's the mental
So,
training is to do that
mhm.
because some of those will be relevant to actual real world, but the thought process is relevant no matter what.
Yeah.
Yeah, that's really cool. All right.
All right. Well,
I
see you
will
tomorrow.
I will see you tomorrow and I'll send you as soon as it'll send me the link to the recording in a little while and then I'll
Okay.
send you that so you have this to look back at.
Perfect.
All right.
All right.
Nice work.
Take care, Todd.
I will you too.
Thank you
I'll
so
see you later.
much.
See you tomorrow. Yep.
Bye.
Bye.